this out. So this is the main input drive shaft on a feed grinder. It's been a pain. Took me 2 days to get this shaft out of this. The reason being is this little sucker right here, as well as that. Although this piece has a pin in it, this one does not. The only thing holding these onto this shaft is the tension that's created from this being hot. It expands, slid onto here. As it cools, it shrinks and holds tight. So in this system there is that piece and that piece that are held together that way. That being why it took 2 days to take 2 pieces off of one shaft. Once that was out, everything else was pretty easy. But just wanted to show you guys some of the things, different types of bearings. This being a pillow block bearing in here, mounting, cast iron mounting around it. I had to replace the sprocket. It was missing a tooth. The teeth were worn really bad, so that had to get replaced. The pillow block bearing. This one over here is still okay. It would be easy to replace at a later time if it needed to be, but while I had this apart, the reason I mainly had it apart was that the pillow block had broken here and here and tore apart another pillow block, which was what I had initially been called to the job to replace. But back to looking at some of the items that are on this machine. This has a bearing in it. There's a pin that can slot into here to engage this, or just have this engaged if you pull that pin out from the hub. But how this bearing goes onto this shaft, it just slides on, but there is no Allen keys that hold it together, or Allen screws. There is one here and there's one here. How these systems work, it's called an eccentric lock, and once the shaft is put through, if you notice, this is machined offset as well as the collar here. So when it is, I don't know if it'll show here, just using my phone here, and I don't have control over focusing, but as this turns, it becomes offset and it bites into this. It only takes maybe 1/8 of a turn. So to tighten these down, you use a punch, and also to remove them, you use a punch in this hole. Make sure you don't use the wrong hole, because this is just a machined hole in the collar that you can stick a punch in, drive it loose or tight, whichever direction you're wanting to go, to spin that. But anyway, I'm getting ready to put this back together. This shaft is going to get dropped into here, tighten the collar down, then this will be flipped over. I will heat up this collar, and hopefully I can get it warm enough to where I won't have to do much beating to get it on there. But it is what it is. But I'll heat this up, slide it down over this. Gotta make sure I have the key in there while I'm doing that. Let it cool down before it roasts these bearings. Get that cooled down. Then I've got to cool this back down again before I put that U-joint collar back on. So here we go. I don't know if I'm going to get much video footage of this, but we'll see. Okay, so real quick, this shaft goes into here. To get it off, I had to heat this up so it would expand. I then drove this shaft out, taking no less than 8 times, because as this is a few hundred degrees, this is ambient air temperature. That heat transfers into the shaft. Then the shaft starts swelling, tightens this back up. You have to have a heat differential between the two of a few hundred degrees to have this big enough over the size of this so that it'll move. So getting it apart took a few hours, because not only of the heat differential holding ability of the cast iron shrinking over the steel rod, but there was a lot of rust and stuff built up in there that made it even more complicated. But anyway, to put this back together, I'm going to heat this up, cool this as much as I can, and hopefully get it on in one try. If it doesn't come off in one try, well, it's going to be a long day. I'm going to tie those ice packs on there to hopefully shrink that shaft just a little bit. Okay, so here's the forge. It's not quite as red hot as it looks in the video, it looks like, but this side is almost red hot. The other side is warming up now. I'm gonna turn it one more time, get the heat nice and even all the way around so that it should have expanded enough to slip right over. Then I am gonna pull it out of the heat, run over here, hopefully not burn myself. I'll have these things taken off, drop it on. First going to use the solid aluminum block to drive it down flush with the end of the shaft. Then I just welded this onto the tool that I had made to remove the piece. Have the pipe or square tube welded onto the end and hopefully be able to drive it home. We'll see. Well, that escalated quickly. I guess we're going to put it on now. All the fire brick in my forge decided to fall over while I was trying to turn the piece. So we're off. I'm just cooling off the top edge so I don't mash it too much when I start driving on it. And there we go. Close-up. Still a little bit toasty, but it's good and solid. It's shrunk enough to where it is a solid connection again. Now let me show you what happened to the forge. I've had this forge set up in its present configuration for a couple years, but whenever I had that collar in there, kind of got in there, got sideways, these fire brick are just kind of stacked up, and well, you could see in the video from previous, there was a kind of a lid to the forge area, and the piece set in there. So as I was turning it around, trying to get another side a little bit warm, the side here kicked out, roof collapsed, and I just had to go with it. Oh, got the U-joint coupler off. Now let's go cook it. It's a little hotter than I wanted to. It's almost 800 degrees. Wanted at least 400. This is a feed grinder. It takes in grain through this chute here, goes up the conveyor, auger, down into here where it gets pulverized and comes out like this. What happened was the bearing that had been here goes in this area. The pillow block broke. The tension of the belt and the tension of the tensioner here caused it to pop up, which in turn broke this pillow block, rendering the machine useless. So the customer called because when that stripped out or broke the pillow block here, it ground on this shaft. I had to patch this shaft up because it had a groove all the way around it, the size of the bearing. So now I get to put that back on that. Okay, I've got everything else ready. This is where one side of the pillow block hooks to. Got the sprockets. This cross piece isn't welded in place yet, but that's one of the new pillow blocks. Patched up this. It was broken there and starting to break there. So before I put the shaft that goes across this, figured I'd get that done while I have room. I also rotated that rod a little bit and cleared out some of the feed that was in the output auger so that whenever it's fired up, it will have a little bit less resistance. And we're ready to set the monster in there. So here it is, all put back together. Get the belt tensioned up. That's what those two bolts there do. Main drive chain that runs all the accessories that are not ran off of the belt. Comes down to this shaft. That's the new pillow block. Everything's all tightened back up and good to go. So this pin right here, this tab is connected to a pin that comes out so that just the chain is being driven, and the belts, which run the grinder, I think it's a hammer mill, this stays stationary when this pin is out, and only the augers and the mixer inside that